Okay guys, since I did the first video on these graphics cards, I thought I'd try and connect the microscope camera up to the PC on USB and see if I could actually get a better recording. And by the time I'd done that, and then I got another camera and attached it to the magnifying lamp over my desk and set that one up, and then I got my hands on a headphone microphone set and set that one up. So a day later I think we actually have a better recording setup now. I can move the bench magnifier up and down and effectively give a zoom, and we can switch to the microscope from here. We've got the microscope now, so we can use that as well, and also we can view the desktop, which is quite fancy when you do that with it. So we can have a look at data sheets on the internet and such like. So I think we've got a better setup there. So we'll see how that goes. I'd like to hear your opinion on that, and maybe anything else we can do to improve this. But anyway, these are the two 8800GT graphics cards, the one with I think are Apple cards, and the last thing I mentioned was these two, what I think are voltage regulators or FETs on the back. We'd have a look at those, but just before I do that, after the last recording, if you remember, we had two coils here, and these ones had the low resistance, about 0.6 of an ohm, which I said would be powering up the GPU. Up here we had about 90 ohms, and I said I think that'd be powering the RAM. We had one down here which I said would be the startup, another one here, and somehow I missed this. I mean, this is another buck regulator circuit. It's quite a big one because it's quite a big coil. It has 3 FETs controlling it, and somehow I was blind, I didn't see that one. So before we look at the other things, let's have a look at this circuit. Let's just bring the meter in. Let's switch it to bleep, perhaps you can hear it. Maybe you can't hear it now on this microphone, I don't know. So this one reads 54 ohms. This one up here was reading 0.6, well say 0.8 minus the 0.1 which the leads read today. This one here up the top, if I can just get onto it, yeah, that's reading like 319. I could have sworn this was reading 90 the other day, but there you go, I now have 319 up there. 319, 457. I now think this is probably powering the RAM, because it's a lower impedance than the other one. We can't say for certain without tracing this stuff out, but there's a good chance that's for the RAM. But 57 ohms seems quite reasonable. It's the same on both cards, as near as damn it. So I'd say that voltage rail is okay as well. So what I thought we'd do is, I don't think there's anything wrong with these, but we can check a few other things, and then what I'll have to do is go online and ask and see if there's some way we can actually test these graphics cards. But I thought we'd have a look at some of these circuits on which are probably good working cards, and give you some idea of how we would be testing these things on a faulty card. So, as I said yesterday, let's have a look on the rear. These things are voltage regulators. I'm going to switch to the microscope, and let's have a look to see what those devices actually are. Okay. Let's have a look to see what these things actually are. There, that's one. Quite often the easiest way, let's see if we can just focus this. A bit more focus. Yeah, it's like B87639. That's that one. What's this one up here? AZ7805. Right. I can tell you straight away, that is a 5-volt regulator. 7805 is a very common component. Now I don't even need to look at data sheet on this one. 7805 is a 5-volt regulator. 7812 a 12 volt, 7809 a 9 volt, 7815 a 15 volt, and so on. And they're positive voltage regulators. You'll also maybe on audio equipment come across a 79, so they are negative voltage regulators. So 7905 is -5, 7912 is -12, and so on. 78 positive, 79 negative, and then this number here is the output voltage. So basically these have an in, which is probably here, a ground, which is probably here I could find out, and an out is probably that one. But we say probably. How am I going to do this with a damn so you can see what's going on? Can we even do this? No, I haven't thought this out very well, have I? Okay, I'm going to just have to tell you what the volt for now. Let's find a better way of doing this. But first off, that one's connecting to ground. That was probably the input. This is probably the output. So that's that chip. Yeah, what I think we'll do, because you can't see the voltmeter while I'm on the microscope, so there's probably not much point in me poking around and trying to show you stuff that you can't see. But what we'll do, let's have a look at some of the other components we're interested on this board, and then we'll go and have a look to see if we can find data sheets. So this one, I know from experience, 5-volt regulator. Input anything up to about 30 volts, but output will always be 5. You'll probably find sometimes, let's use something better than that pen. This centre pin here is broke off. It's not broke off, I mean it's just, that's how it is, it doesn't go anywhere. That's because the centre pin will always be connected the same as this tab. That's why there's a gap there. It's not necessary. The tab and the pin are the same thing, so soldering the tab is the same as having that pin there. So let's have a look at this other chip we had. Look on the back here, this one, BA7639. Yeah, okay, I'll make a note of that one, but this is experience actually from myself. This one has another number at the top of it. Let's have a look at this, because yeah, now this is something I've seen many times, and again, you'll learn to recognise this. Let's turn it the other way, right way up. There. Can you? There. I've got a torch. I'm shining a bit of light in here so we can see the numbers. And you see that funny symbol at the start, that looks like a letter A in a circle. This one, this little emblem here. That emblem is a company that's called AO, or the initials are AO. So this device is probably an AO as the manufacturer, D484. So it's very likely that is the part number and not this one. So I'll make a note of that one as well. And then when we look up data sheets, if we can't find the BA number, we'll try this one. So that's that one. The other chip we were interested in was over here. Again, let's just turn it right way up so we can see it. This one, I'm pretty sure it is going to be the controller for the regulator circuit that powers up the GPU. So let's have a look at it. So again, this one. Now we've got PX3544BDSG. Make a note of that. But from experience, I would probably search for like PX3544 because it might be if you put the rest of the letters on, you don't find anything. They could be a manufacturer's code or various things. But anyway, I made a note of that one, so we've got that one. Let's go back to the main side of it. Let's top corner. Okay. So this is one of the two coils that reads about 0.5, 0.6 of an ohm that's powering the GPU. And next to it, we see a little group of chips. That just obviously, I know the focus a little bit. This is because I'm turning the board over. It's all to the height. Okay. These will be power FETs. Often these 4-digit numbers beginning with a 4 with N at the end of it tend to be power FETs. Again, that's just experience myself. What you would do is look up this number and you can see. So we've got a couple of 483 35Ns. Make a note of that one, and we've got a 4841. Let's try the light from different directions. Can we make out? Ah, yeah, that's a H at the end of it. I can see that now. NH 4841NH. So we've got that one, and then the recording stopped, and I didn't realise. I spent 10 minutes, 5 or 10 minutes talking to myself, and eventually noticed it wasn't recording and felt a right prat. So I'll try and keep an eye on that, and I have no idea why I did that. But, and then we know about these 3 MOSFETs, and if we can look down here, it's an identical circuit, and next to them is this chip. So we're pretty sure that this chip, and it's the same there, is something to do with this circuit, because it's next to it. This is by these, and it's by the coil, and the same thing repeats here. So I don't think that's any coincidence. This chip has something to do with this circuit. So let's have a look what this chip is. I'll just get my there we go. This trick with the torch. So when you've seen this now, you're all going to be doing this. 11AD FPJK. Make a note of that one. From experience, that's going to be a bit hard to find the data sheet for that one. So we have all the numbers of the chips. So what we'll do is now we'll have a look online and see if we can find some data sheets for these. So let's just switch now from the microscope back to the screen capture, and let's go and have a look on the internet to see whether we have any information on these chips. So we'll start off with that 7805. This is the one I said I don't even need to look it up. Let's look it up. Why not? This like common, where you start to recognise chips. This will come in time. This is not. Don't try and memorise these things, but when you've seen them a few times, this will come. It comes in time. That's the actual chip, voltage regulator in, ground, out. Yeah. Let's see. Look at LM7805. You'll probably find UA7805 and so on. So this thing will be made by a lot of different manufacturers, and they'll have their own letters in front, but they'll all be the same. Let's have a quick look at the datasheet, so I'll show you what the datasheet looks like. This is, in fact, you see, look, there's loads of datasheets, probably just different manufacturers. Let's go to the PDF. And let's see what we have. Okay, here's a data sheet. 3 terminal positive voltage regulators, like 5 volt, 6, 7. I told you these things come in a whole different range of voltages. They can output up to 1.5 amps. They've got internal short circuits, monitoring, thermal overload protection built in. Like you see, this manufacturer is KIA or K1A. But then 7805, 06. So I've told you, 78 is a positive regulator, and the next 2 numbers are the voltage. 79 is a negative, the next 2 are the voltage. And there it is. And there's a little picture of it again. Look, just the same thing. 1 input, 2 ground, 3 output. So no matter who makes these, the pins will be the same. They're just compatible with each other. So that was that one. Didn't really need to, but hey, come on, if you've not done this before, let's do it from the beginning. So that we know about. Next chip we saw was this BA7639. Let's have a look at this one and see what we have a date sheet for this one. Nah, so that's found nothing. It says images for datasheet BA7639. Let's have a quick look. What you can see there, it's the picture that has nothing to do with what. In fact, that's a BA3906. I hate that, when you're looking for a data sheet, and because you can't find what you're looking for, it shows you something else. Why? Why just say, sorry, there ain't one. Okay, this is the one that I said might actually be made by a company called AO, and it might have the other part number. There was 2 part numbers on this. AO D484. I've seen AO components a lot. Like AO D44. And it tells us it's a MOSFET. So we have a datasheet for that one. Again, we can download this and we can have a look, and it'll show you what it looks like. Great. Gate, drain, and source. I'll explain when we look at the circuit, but basically this is a switch. So drain and source is your switch. When there's a voltage on gate, this is turned on and it will conduct. When there's a voltage not on there, when there's no voltage there, it'll turn off. So it's just the electronic switch. And they can turn it on and off stupidly fast, like, you know, hundreds of thousands, millions of times a second. So that's that one. Out of interest, if you didn't know that was by AO, would you still find the datasheet? Let's have a quick look. Just out of interest. If we just search for D484, yeah? Yeah, it's there. It's the same. So even if you didn't realise from I recognise the logo, you probably don't. It doesn't matter. You would still find it. So that's that one. What else have we got? The PX3544. This is the one on the back of the board that I said was the controller for the buck regulators that power the GPU. There it is. Again, data sheet. Let's just find. This seems to be. I often use all data sheet, but they don't have for all. All data sheets don't have the data sheets for all. So sometimes you have to find different types. Here we are, Primarian. It said that on the chip. It's a 4-phase graphics processor, digital multi-phase controller. That's exactly what I said it was in more words. Some information. Do you want to buy it? I think they're trying to sell it to you here. A block diagram and a circuit diagram. These are handy. You'll often find. Let me just do something a bit different. So when you can't see the whole sheet, I often just download them. If I download the datasheet, save it. Oh, I've done this one before. You often find this. You'll find the same components over again on different boards and things. Look, now I've downloaded it, we can see a lot easier. Now, this reference design. What you'll find is this is like made by the chip manufacturer to tell design engineers how to use it. And design engineers probably being lazy like everybody else. Sort of think, well, why reinvent the wheel here? Just copy that. So you'll often find that this is the same exactly that you have on your board, probably with no difference or very little difference. And this is almost as good as having a circuit diagram for that area of the board. So that's really useful. So that's what datasheets can give you. Okay, so that's that one. Just a few more. We had that funny little thing that I said we probably won't be able to find. Which was it was either 11AD. Okay, so it's found something. Let's have a look. Nah, it hasn't. Okay, I'm in Spain, so I often get a lot of Spanish come up here, but no datos is basically no data. It can't find that, but what it has done, it's found lots of similar numbers and showing you them in case you might be interested in those, but we're not. So that's of no use to us. Let's try the other number of us chip. Let's see if we can. FPKJ. This is probably what's called an SMD code. It's not the part number. Yeah, nothing's there. SMD codes. If you go on repair forums and ask, you'll quite often find people tell you what that actually is and give you the part number, and then you can then find the datasheet. But anyway, for the moment, we can't find anything for that one. And then there were two more, and these are the ones that I said were probably FETs. So there's 4835 power FETs, MOSFETs. 4835N. Yeah. This has been searched for before. 4835N. There we go. You'll often find with different manufacturers. Look, it's a power MOSFET. That's what I said I thought it was. Let's have a look. This will tell us which pin is which on the device, and it'll give us some ratings, how much current, obviously gate, drain, source. So the gate controls it. The drain and source, this is a switch. When there's voltage on the gate, the switch is turned on. When there's no voltage, it's turned off. That's what a MOSFET does. Let's go back and have a look at the other one, the last one, but I'm sure there will just be another MOSFET. Over here. So 4841 NH. 4841 NH. Yeah, there we go. 4841 MOSFET. Same. That gives us which pins, the same information, 30 volts, 13 amps, blah blah blah. So what we'll do is now, I think I'll print off some parts of these data sheets. We'll get the desk cam back on again, and we'll have a look to see if we can identify the parts on our board and see how they're connected together. So we're over to the desk cam. There we go. But give me a few minutes now, and I'm just going to go and print off those data sheets. So I printed off the data sheets, as I said, and I'm just checking my microphone's working. Yeah, it's good. Okay, so I printed off the data sheets, as I said, and we're going to have a look at the boards in a minute and see if we can effectively find the same circuit on our board as we can see in the data sheet. So this is might be easy to show you actually on the computer, but I want to show you now. This is the PX3544. This is the chip that drives the GPU power supply. And on ours, if you remember, there's 2 channels, and this you can see 1, 2, 3, 4 channels. Now the thing is, this chip, although it can handle 4 channels, there's no particular reason I suspect why a designer can't just use 2 of them. And I think that's what's happened on our board. They're just using some of the facilities. Let me just zoom in because I know this is not perfectly clear. But what we have here, look, we have 12 volts coming in up here, yeah? This is the chip. We have 3 volts coming in here, VDD. This 3 volts, I can tell you now, this powers the chip. From the GPU, I'll tell you what this will be. This will control the voltage, so the GPU itself can, for instance, if it's under a lot of load, it can actually increase the voltage supply to itself a little bit. So the GPU has some control over its own voltage supply. That's what that will be. Fault outputs, this will be where this sees some sort of problem, possibly use it to shut down part of the circuitry or whatever. And these 4 things here, these are drivers. One moment.